Today I'm going to be covering question 89 from University Physics Volume 1, Chapter 2, Challenge Problems. So this chapter is all about vectors, and in this question we are asked to find, we are asked, what is the component of the force vector G equal to 3I hat plus 4J hat plus 10K hat newtons along the force vector H equal to 1I hat plus 4J hat newtons. So, to start, let's just see what we're given. We have a vector G in 3 dimensions, which is going to be okay, I didn't really draw that right. Imagine that's 10 high though. It's going to extend up to about here. Call this G. And we have H, which is only in 2 dimensions. We'll extend to about here. Now, we're looking for the component of G along H, which essentially means along H. So it's best to consider this in just 2 dimensions. And now if we redraw our vectors, excuse me, if we redraw our vectors in just 2 dimensions, we'll get G is approximately here. I'm getting this by just looking at the components, by the way. So it's 3, 3, and it's 4, 4. Now H is going to be 1I hat plus 4K hat, which is going to be right about here. And now we're looking for the component along H. So imagine along H. If G and H were in the same direction, where would the component along G be? How long would it be? Right? So let's see. We're gonna have to model a triangle out of this. We have G and we have H. And now we realize that if we were to rotate this over, well, it would be longer than H. So we can extend the direction of H out. So we know it's going to need to be longer. And to find exactly where it's going to be, you need to make a 90-degree angle with the H vector and the G vector. Now, the reason we do this is imagine we had the x-axis and some vector v. If we wanted to find the component along the x-axis, well, we would just make a 90-degree angle, correct? Because this would be down here, the component along x, and this would be the component along y. So we are essentially doing the same thing, right? If we wanted, even, we can rotate our drawing here. And the only thing weird about this problem is that, well, the G extends beyond H. So we're just going to have to extend this out. And now we have a triangle we can work with, right? We can call this angle between these vectors theta. That's going to be important. Now that we have our triangle, we're going to need to start looking for what this value is. And let's call this value g at h, the component of g along h. Now, how could we find a relationship with this value to something we already know? Well, we can use trigonometry. So if we say, consider a cosine of theta, which is equal to adjacent over hypotenuse, which in this case is going to be g of h over the magnitude of g. Now this just means the magnitude because the vector g is not a length, but the magnitude of g is a length. So then we can say that g of h is equal to magnitude of g times cosine of theta. And this is where it gets a little tricky. We're going to have to realize something from a relationship we already learned about, which is the dot product. Now, the definition of the dot product states that a vector, in our case g, dot h is going to equal the magnitude of g times the magnitude of h times cosine of theta. Rearranging this, we see that g dot h over the magnitude of h is equal to g cosine of theta. And now, if you're asking, what is the point of this? Well, the point is, we don't know what this angle theta is, right? We're unable to know what that angle is right now. So we need to find another relationship that allows us to use what we have to solve this equation. So bringing these two equations together, we get g of h is equal to g cosine of theta, which means that g of h is therefore equal to g dot h over the magnitude of h. And this is where we're going to have to start solving it. Now, we can start with the dot product. We know that the numerical definition of a dot product is to multiply each of the components and add them together, like this. So for our case, we're going to have g dot h is equal to, oops, let's check our vectors. We have g, now I'm just rewriting this in a different form so it's easy to visualize. And h is going to be 1 I hat plus 4 j hat. So 1, 4. And now let's consider that there would be a 0 there as well. Because even though it's not written, oops, even though it's not written here, we know that when we're multiplying these, we're going to need a 0. And a 0 is perfectly fine to put there because 0 times k hat is just going to be 0. So now, taking the dot product of this, we get 3 times 1 plus 4 times 4 plus 10 times 0, which is going to be equal to 3 plus 16, which is equal to 19. And I'll just rewrite that on another layer. And now if we want to find the magnitude of h, this is defined as the components of h squared and added under a square root, which just means the distance that the vector h is covering in space. So we can calculate this. We know hx is going to be 1 squared plus hy is 4 squared, and hz is going to be 0. And this is going to equal root 1 plus 16, which is equal to root 17. Now, putting it all together with this equation, we end up with g of h is equal to 19 over root 17. Now, don't forget units. Because we're dealing with a force vector, we're asked what is the component of the force vector, which is going to result in another force vector, just the component of it. We get 19 over root 17 newtons, which, plugging this into a calculator, gives us approximately 4.61 newtons. And that's going to be it for this problem. Thanks for watching. See you guys.